Alright, so in this lesson we'll talk about questions involving comparing coefficients of terms in two series. Okay, so this is related to the Maclaurin expansion topic, and this is actually quite a common question you can get in your exam. Okay, so this is best learned through example. So we have an example on the right column. You can see that the first two terms of the series expansion of square root 1 minus x plus x squared and ln p plus qx, where p is greater than 0 and q not equal to 0, are equal. Okay, so they're talking about the series expansion of these two expression, and the first two terms are of these two expanded series are equal. Okay, so we're going to supposed to find the exact value of p and q. Now the steps to solving this is actually quite straightforward, so let's write down the steps. Okay, for questions that are similar to these, okay, what we'll do is that in step number 1 we will expand and simplify. Okay, expand and simplify each series, okay, independently. So that means in the case of our example, we will expand square root 1 minus x plus x squared, okay, and then we will also expand ln bracket p plus q in terms of p plus q. All right, now how many terms should we expand will depend on the question. So in this case, it talks about the first two terms, which is not too bad in this case, right? So all we need to do is to expand the first two terms, right? Now the next thing, once we have that, is obviously to compare the coefficient, okay, the coefficients, right, of the corresponding terms. So corresponding terms. Okay, so you got to be very careful here. It doesn't necessarily mean that within each of these series expansion you will compare the coefficient of x cubed to the first series to the coefficient of x cubed of the second series. All right, it changes from question to question. Okay, it can happen that way, but sometimes it may not. They might tell you that the coefficient of the x cubed term for the first series is equal to the coefficient, let's say, let me write that down, coefficient of the x squared term in the second series. Okay, so pay attention to the question and follow the conditions that they give you. Okay, in our case here is actually pretty straightforward. They tell us that the first two terms, okay, the first two terms are equal. So in that case, the first term corresponds to the first term of the other series, the second term versus the second term. Okay, so pretty straightforward there. Now what we'll do over here is that once we have done the comparison, okay, in step number 3, we'll just go ahead and solve, right? Solve for the unknowns, okay? And in our case, for this example, it will be both p and q, okay? So let's go ahead and solve this question, and then we'll see how these steps, okay, step 1 to 3 unfolds, all right? Now, step number 1, let's go ahead and expand each of them independently, okay? Let's go ahead and use red color so that it's easier to see. So this is none other than this, right? 1 minus x plus x squared to the power of half. So if you recognize this, we know that in order to expand this, okay, we are going to use the binomial, okay, under the in our Maclaurin expansion formula sheet. Okay, so over here we can go ahead and replace this part, okay, for the x inside here. All right, so we just need the first two terms, which is pretty straightforward. So all we have is 1 plus nx, okay, so n is half, and then x would be minus x plus x squared in this case, plus dot dot dot. All right, we don't need the rest of the terms. So let's go ahead and simplify this. This will be 1 minus half x, okay, minus half x plus half x squared plus dot dot dot. So in that case, since we just need the first two terms, we can ignore the third one, right? But I'm just going to leave it there. Now, let's move on to the ln p plus qx. So we have ln bracket p plus qx, all right? Now, for this expansion, okay, look at the formula sheet, for the ln, we must have it in this format, ln bracket 1 plus x. But we realize that we have a p, right? So in order to be able to get ln p plus qx into the required format, we need to pull out the p, okay? And that gives us 1 plus q over px, close bracket. Alright, so if you multiply the p back in, it will give you back p plus qx. Alright, now when we do that, then we can apply the product law of logarithms so that we can split this into two terms. So we have ln p plus ln bracket 1 plus q over px, close bracket. Okay, so in that case, that allows us to use the formulas, okay, given to expand the second term over here. Okay, now let's go ahead and do that. So we will replace x with q over px. So that means we have q over px, okay? And then we just need to put the plus dot 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 because all we need is the first two terms. So right now we are ready to compare our terms, okay? So we move on to step number 2. So by comparing the terms, or rather the first two terms of both expansion dot, okay, ln p must be equal to 1. Alright, we can go ahead and solve this because this is actually quite straightforward. This implies that my PE must be equals to E, okay? Because ln E is equals to 1, right? Now, next up, we can solve the second term, which is Q, okay, let's write that properly, Q over P, okay, is equals to minus half. Alright, so this is actually step 2, right, where we compare the coefficient, and then we can move on to step 3 to solve the unknown. I've already done that for P, okay, because I want to do that because then it makes it easier to solve the second equation, because then we could replace the P with E, okay, which is equals to minus half. Alright, so for some of those who was wondering how I got this, okay, that is I'm actually comparing the second term, okay, on both of the expanded series, right? So we know that the coefficient of x on both series, okay, are equal, so it must be q over p. It must be q over p minus half. All right. Now coming back here, we are just one more step. Okay, so q must be, we multiply the e over, that gives us minus e over 2, or minus half e. All right. So that is our answer, and that is how you solve questions involving comparing coefficients of the terms in two expanded series.